we're going to look at one more oxidation reaction, and that's the Benedict's test that you did virtually on the lab. Basically, we looked at some videos about it because we couldn't do it in class. Again, here's the thing I want you to know. This is glucose, and again, you don't have to remember what glucose looks like. I'm not asking you to know that. What I am asking you to know is, just like in the Tollens test, the silver was what caused the sugar or the aldehyde to become oxidized. We want to know that the copper is the reason, is what makes the Benedict's test work. Okay, so for Tollens test, the silver ion, and for Benedict's test, it is the copper ion. And remember, again, we're saying ion because there's other stuff in Benedict's reagent, okay, but we're not focusing on it. Remember, this is organic chemistry, so these equations, they do not have to be balanced. That's kind of the one good thing about organic chemistry. But what's important here is that the copper in copper 2 sulfate has a +2 charge, okay, and the color is blue. So you take glucose, which is a clear solution, and you add this Benedict's solution, which contains copper 2 sulfate, and it is blue. Then it does some heating, and I think that we actually did this whenever you were in biology last year. You may not remember it, but we were testing, it was whenever we were doing the different macromolecules. Now, what happens, notice that this copper 2, which is blue, now we also use this whenever we were doing the flame test, the blue colored solution. When copper is in the +2 charge ion, it has that blue color. Now, when you have copper 2 oxide, however, it's that red color. It's that, and then whenever you see copper with a, just an elemental form with that 0 charge, it's that bronzish, reddish bronzish kind of color. All right. But what's happened here is that the copper has been reduced. Okay, so copper reduced. Remember, with an oxidation reduction reaction, if one is reduced, the other has to be oxidized. Okay, so the charge on the copper is reduced. It's brought down from a +2 to a +1 charge. And we now have copper 1 oxide, and this is insoluble, so it sinks, sinks to the bottom. It produces this red stuff if you have a reducing sugar. Okay, so likewise, what had to happen in order to reduce the copper, this aldehyde right here, so this is an aldehyde functional group, that aldehyde had to get oxidized. And it got oxidized to this carboxylic acid functional group. So let's go over what's important here. Again, you're not memorizing glucose and this. You're not memorizing that. All you're trying to take from this is that in the Benedict's test, the copper is what gets things going. It's what produces the color. It's what indicates the presence of an aldehyde. And the way it does that is the aldehyde functional group gets oxidized to a carboxylic acid. Remember, we're just simply taking the hydrogen away and sticking a hydroxyl group on. Alright, and again, I know this is, I'm really simplifying it. If anybody's watching that is looking at mechanisms, this is not the video for you. This is a very simplified version of what happens. But this aldehyde gets oxidized to a carboxylic acid, and if one thing's oxidized, something has to be reduced. So the copper, which is this blue color before the reaction with a +2 charge, gets reduced to this reddish color, copper 1 oxide, with a +1 charge.